What's happening, YouTube? Appreciate y'all ninjas tapping in again today. Today's topic I'm going to talk about is the root port election process in STP. So today I put together a little lab so that I could just demo it. We'll jump straight off into the topic and get it started. Right here I got the lab. As you can see, we're in packet tracer. We got switch A and switch B, and the question is, which of the following should you do so that the link between 1 and 2, this top link here, is the primary link for VLAN 14 traffic and the backup link for VLAN 13 traffic. And then as we can see, they're giving you the only multiple choice options here are for port priority, which is a tiebreaker in the root port election process. And when I say tiebreaker, meaning that there's going to be a root bridge and a non-root bridge in this when you're using STP. In this specific scenario, we got switch A is the root here and switch B is the non-root bridge. You can barely see it, but this port's blocking this link down here, and this port is not blocking this in the forwarding state on this guy. So that means he lost the root port election process, port number 4, and that's why that port is in a blocking state to prevent the looping between the two switches. So if we jump into switch A and switch B, put switch A down here and then switch B, right? We'll focus on switch B right now. And the question was saying the primary link for VLAN 14 or for the VLAN 14 spanning tree. If we wanted to look at that, you verify with this command show spanning tree VLAN 14. And we can verify port 2 right here is the root port. So this is going to be the primary link, and then this would be your backup link for VLAN 14. So they said for VLAN 13 they want this, which is now the backup link, they want this to be the primary link and this to be the backup link. So how this works is for this example right now, how it's currently set up, there was a root port election process and the tiebreakers for that. And when I say tiebreakers, I mean this: when they're going against each other saying who's going to be the root, they have to let each other know the cost to reach the root. His cost is 19, so they can't use that. So they have to go to the next tiebreaker, and the next tiebreaker would be the lowest sender bridge ID. So not the local switch, the switch that's sending the BP to use. You have to go over to this switch. In this scenario, you might have a scenario where there's 3 switches. In that case, if there was a switch C and let's say switch A stayed with the lowest MAC address, AAAA or whatever, and was still the root bridge, then switch C, if there was a switch C here, and he had a cost to reach the root bridge as well from switch B, he would have a cost of 19 if he was using a fast Ethernet port to get to switch C, and then an additional cost of whatever interface was connected to switch A. So the lowest sender bridge ID to elect the root port would still be fighting between these two, because the cost would be the tiebreaker, and this one, if there was a link from switch B to switch C to switch A, would lose because there's too much cost, and the higher the cost you lose. And anything in STP, the lowest wins, any lowest value wins. So I hope that makes sense, but just sticking with this scenario specifically, because you'll see it and it'll look like this sometimes. They'll have it diagonal and everything, but just know when you have 2 switches right here, and I mean, you could just draw this out, right? If you were on the test, you could just draw it out. But if you had 2 switches and they said that one was the primary, the 1 and the 2, the 3 and the 4 would be blocking. So the way that we'll be able to make this the primary link for VLAN 13 is going down that tie-breaking thing there. So lowest sender bridge ID, and then the next one would be the lowest sender port ID. And when they say port ID, they're talking about the port priority and port number. So the port priorities are tied, so it would be the lower port number here, which this number is random right now. It matches up with the interface number, but This number I think is like an auto-generated number through the software or the iOS. So to change it, since it's the lowest sender ID and I want to make this one the root port, I have to go to switch A. And if I lower the port priority specifically, because this is what these are asking me, if I lower the port priority, which one is going to make this guy the root on this link? And so we already know these two are out of the question, because if port priority 192 went up against port priority 128, 128 will lose. So these two are both out of it. So it's between changing the port priority for VLAN 13 or the port priority for VLAN 14. So since they want the primary link on VLAN 13, we're going to just use this one. Spanning tree VLAN 13 port priority 64. And we're going to go on to switch A. Spanning tree VLAN 13 to specify the VLAN you want to be on. Port priority 64. Do that. Go back onto switch B. As you can see, it's going through the status change here, and the listening and the learning and all of those different states that it goes to for it to that election process to take place, because I changed the cost on the senders. And as you can see now, this is even changed right here. So if we run it again, now we see that this is the primary link for VLAN 13, and this link's blocking now, so it's no longer the primary. And we've done nothing over here. The most important thing I wanted to share was that everything's done for the root bridge. If your costs tie, port priority ties, if you're stuck on a question or even in real world and you're trying to make some adjustments where this would be the primary link, if you're tasked with all of that, just know that you have to go to the sender or the root bridges configuration to influence the election over here. Usually they can do it by themselves on the switch, the cost. By doing that, say, hey, if I got the lower cost, I could be the root, do it that way. I could have did it that way too if I would have just dropped the cost, because you can manually configure the cost if you wanted to do it that way as well. But again, they were only talking about port priority in this question and everything, and that's not a usual thing to change, right? Usually people just change cost immediately because that's just an easier way to do it, I guess, than to be messing with the port priority, because the port priority consists of the port priority and the number. Who knows? But for this specific scenario, definitely want to use that. And just for grins, I'll just show you. We will go back to switch A. Let's go ahead and see what would happen if we change this back. Just do a no spanning tree, right? Spanning tree VLAN 13 port dash priority 64, right? And then we'll go interface. Let's see what this one wanted us to do. Same interface, FA03. So we go back on switch A, interface FA0/3, and then we do spanning tree VLAN 14 port priority 64. And I just got that again from just selecting this different answer and to see if this will do anything here for us. Now, if we go over to switch B, let's see what switch B is talking about on VLAN 13. Nothing. Primary link for VLAN 13 is not what we want. Let's look at the primary link for VLAN 14. No, VLAN 14, now this is the primary link for VLAN 14 down here, as you can see. And that's not what we want, right? We wanted VLAN 13 to be the backup link. So that's pretty much it. I hope you guys enjoyed the video. That's about it. Oh, as always, if I can, please keep them algorithms going for the channel. Appreciate all the feedback, everything that y'all do. Y'all ninjas keep on working. You already know I'm out of here like ninja.